Oi. Okay. How is it going? Um, how's it going? How's it going? Whew. I am, making good progress today, so let's keep it up. Finish it off. Another sort of 2 hours of streaming planned for today or so. 2 hours of work. That is some apple and raspberry juice. It actually kind of tastes like cranberry, um, for some reason, which is nice. Cranberry tastes nice. Even though, yeah, it's sold as being apple and raspberry. Quite tired at the moment. Yeah, well, I don't know. Most of my day has just been like streaming and shopping. I feel like such a pro streamer. You spend like 4 hours streaming, an hour shopping. What do you do with the rest of your day? I don't know. Spend it on Twitter. Who knows? Who knows? Talking about God knows what. Doesn't matter. I'm happy to just push on. You see how it says, so the description that I've put just underneath my face, um, I'm saying, what was it? What does it say? I'm on part two, as in project two, part B, right? So this is the MIT Distributed Systems Labs for the coursework. Project two is on Raft, which is a consensus algorithm. And part A was on heartbeats and electing leaders, because this algorithm is like some sort of next democracy. So part B is about handling the data that gets sent into the algorithm for it to establish consensus. And so we have this, this which kind of describes what's going on. What is it? Yeah, writing all these like computers getting on together, passing messages, RPCs are what those messages are called, between each other, remote procedure call, and collaborating on getting information to be synced up and accurate. And so the data comes from its input into Raft to the leader, which writes it, sends it to followers. The followers write it and then acknowledge that they've received it and written it. And then the leader commits when the majority has acknowledged, and then the followers commit based on the leader having committed. And then the leader has finally decided, oh, we're done with this data, we can actually apply it to the service. As in, it's sent back out of the algorithm. So that's what 2B is about, and I am doing my second pass of sketching it, as it says down below. And what I mean by that is I'm just trying to go through all the stuff that I'm going to need to implement. All this stuff is pretty complicated. I'm spending quite a lot of time sketching it before I start with the implementation, which I think is the right way to do it. But sketching it once was not enough. I'm now sketching it again, my second pass, trying to understand it a second time. Some really sort of complicated theory is best understood just by passing it repeatedly. I kind of drew an analogy with like a disk defragmenter. That's what I feel like I'm doing. Defragmentation. So faces, yeah, it's okay. Defragmentation is just one of those processes that requires many passes to do. Obviously, you sort of bundle things up and then you do it again and again until you get the hard drive nice and optimized. So that's what I'm doing. Actually, there's a lot of stuff I've written down through my first pass that I should probably delete. Because in this kind of document, which is getting quite extensive now, the bits that I'm keeping up to date are like all of this stuff, but then here, this bit is my initial attempt. This was my first pass. I was trying to kind of match the theory to the cycle as I've described it here, but then I realized that this cycle although it kind of explains what happens to individual bits of data, is not a good analogy to use for how to implement the code as a whole. So I've been kind of re-summarizing it here. You know, putting the bits of information where they should be going, pretty much, with a bit of a summary. And so I'm just going to push on and continue with that. Okay, I should explain my stream page below has all the information about what I'm doing. In particular, this blueprint is linked to down there in the bottom right. And that's basically my source on all the theory. So what I'm doing is I am basically condensing all this and putting it into a framework that kind of is going to approximate how I'm going to implement it eventually by sort of putting the bits of data information, putting the sort of little bits of information here under the kinds of bits of the program that they're going to go under in the implementation. But in the process of doing that, I rewrite it and try to understand why that is part of Raft in the first place. So I've had a fair amount of success. I feel like I've got a good hold of committing. So I've written about how commits are done here and here, you know. So the leader is keeping track of it, commits, and the followers are basically syncing their commits. The same thing. So commit index is the variable that all of the servers are using to keep track of commits, and the follower is syncing that with the leader. Whereas the leader is incrementing it based on has everyone written down all the relevant information. That because don't forget the data cycle is data comes in, it gets written and then committed, and then it gets sent out, which is equivalent to saying it gets applied. So it's in, write, commit, out. And write is done ASAP. We try to get the data in all the logs, and we have to resolve conflicts between the logs, which can get out of date if one of the servers crashes and then comes back. And then committing is all about establishing a final log once a consensus has been established, and then it gets sent out. So that's sort of four-step process, I would call that. You know, the input, the writes, which are these two, the commits, which are these two, and then the output. And okay, the reason I put A and B here are because these two steps are independent of each other. They don't have to. They don't. One doesn't wait for the other one to happen. This juice is great. So it must be from like concentrate, I swear, like the cranberryness of it, I don't know. If not, they've got it really right. I'm happy with that. So yeah, committing is kind of handled by these two. But then writing is handled by these. Basically. That's where I got to at the end of the last stream. Figuring out what is which phase and getting that link, getting the link ups happening between what are essentially different ways of understanding the same thing. So the way it's been written in the blueprint, trying to get that together with my interpretation of how the data cycle works. And this is something I got from the illustration, you can also find below. The illustration kind of describes it this way for each piece of data. And getting that linked up with my interpretation of what's going on. So basically reconciling those two, the illustration and the blueprint, has been a big part of what's been going on here. So I'm just going to push forward with that. Finish it off, you know. I came pretty close to finishing at the end of the last stream, but I had to cut it short because of a TV show that I watched. I was watching House MD. So basically, the realization I came to was kind of an understanding of how, basically all of it, to be honest. I kind of understood how the whole thing works, to be honest, when it comes to the write phase. how does the leader keep everyone updated? Well, it has next index, which is what should I send next to this person. Send append entries with payload starting at next index. And that happens if my last entry index is greater than or equal to next index. Because my last entry index represents the most recent piece of data I have, and next index is the piece of data I should send next. So next index -1 is in principle the most recent bit that I have already sent to a given follower. And so that's why we have this non-strict inequality, and it says whenever this happens, just send out the append entries with the payload starting at next index. And payload, what I mean by that is all of the most recent data starting at next index, finishing at, well, whatever my most recent data is. Whatever my most recent data is. Let me get to the end of a sentence without my throat closing. Yes. Yeah, that's basically it. And that's how the leader goes, and then what the follower does is pretty similar. It's still still a little bit confusing. I'm wondering if there's a more reasonable way of splitting this up. I think I want to refactor the way I've written this code, to be honest. Sorry, not the code, just my outline. I want it to match up more with the data cycle. Couple of reasons. One, I think it's easier to understand if I have the bits that match. All the things that are about writing to log should be next to each other, whether it's the leader or the follower doing them. And all the things about committing should also be next to each other. I feel like that'll make it easier to understand it as a whole. But also, I'll be implementing more or less like that as well. So it'll be like, okay, first do the writes, then do the commits. At some point, do the inputs and the output, those four things. So it'll be good to split them up if I can. Although I also want to bear in mind which part of the code everything should be implemented in. So I'm also going to make notes of that. So let's do a quick refactor of this then. I feel like that'll be good. Because we definitely don't need this anymore, particularly once we've refactored it. So let's just do that here. Make a new section. So data cycle is going to look like this. It's going to be what's a good way of writing this down? Just like this, I think. In, write, commit, out. So the data cycle, I've rewritten it slightly into this stuff, into a 4-part process. And so I'm just gonna assemble which bits of what I already have correspond to which bits here. So leader tracks is a way of basically saying the leader keeps on top of. It's what I put here. It's what I put here. Just a slightly abbreviated version of that. When it comes to write, this is the bit that's relevant. And what the receiver does. So and in brackets, In brackets, I'm going to kind of put what it's going to be. So leader and follower is the states that's under which all these things happen. So in Raft, every server can be in any state. But basically, they do different things depending on which state they're in. I think I called it a phase rather than state is a bit generic. Phase, right? Leader, follower, candidate. For our purposes, we don't care too much about candidate for the time being. That's something I worked on more in the previous section, part 2a. But 2b, we are mostly just leader and follower in what we're implementing. And in brackets, I'm putting where in the code I think it should go. So here, for example, append entries receiver. Leader tracks. When I say tracks, I don't know where in the code I'm putting this, but tracks is my way of saying basically this should kind of be happening all the livelong day. Well, as in, it should be happening all the time, when possible. This should be being kept updated, basically. So that's what the leader does, and the follower does this. So we're doing right phase. The follower does quite a lot of stuff, and I haven't actually strictly written about it all yet. Pretty much, append entries receiver covers more or less the whole process. Everything that a follower does is more or less covered by append entries receiver. That's why I'll keep the numbering in here, because that corresponds to the order that the specification says that these steps should go into the append entries receiver function. This is the function that handles the receipt of an append entry, so it gets triggered every time append entries is received, and append entries is how data is transmitted from leaders to followers. Just a quick summary there. Commit, yeah. Commit is the same thing. When it comes to the follower, what the follower is doing is step 4 here. I'm just going to move it into that section. FN page down would be nice, thank you. Here. So, yeah, so the numbering is consistent across append entries receiver sections. And we also have a leader tracks for the commits, and that's this thing that I haven't written yet. Oh, how much work have I done today? How long have I been on stream? It's been about 2 hours 20, so I'd say it's still a pretty solid amount of work to be done, just for the time being. Cool. Another couple of hours, I think. Well, by the time I've gotten all this sorted in my head, I didn't really pop off because I had such a deadline when I wanted to watch House, and I had to leave. But like in the last 10 minutes of my previous stream, I just realized all this like deep stuff about how right in the write phase for some particular data in its write phase, this phase, how it all works basically, why the leader sends what it sends in the append entries message. And I kind of, all of that just sort of came together in my head at that point, and so I was kind of hypedly describing it all on stream, but I didn't really because I had that deadline that I wanted to watch House. I couldn't go I figured it out, So a bit of pop in the stream would have been decent, but just no biggie. Yeah, that's basically it. So in and out, I haven't actually really done anything on those yet. There is some information. There is some information somewhere about how in and out work, but I'm not too fussed about those. I want write and commits to come together in my head first, because I think those are more difficult to understand. Out is also known as, I should say, apply. They are basically the same thing. So you can see my data phase is actually getting replicated, writes, commits, applies. And step 1 here is the in phase. Cool. I might do equals as again, just to make it a bit a little bit clearer, I guess. And also a bit of double spacing. Yeah, okay. Well, you know. It's all, yeah, I'm still quite muddled on some of this stuff, but as far as my second pass is concerned, I think, yeah, let's just get to the bottom of let's just get to the bottom of this stuff, as in the rest of the right phase. Okay, let's just. The first thing I'll do to fill, I will literally just fill this in, and then because we have it all in one place, we can have a bit of a think about what everything means. So first of all, if an existing entry, so okay, yeah, again we're putting stuff into the follower section. I've already done success, which covers the first two of these points, and so 5 is about the commit phase, so that's also done. I've written it somewhere else, and so we want 3 and 4. If an existing entry conflicts with a new one, so this is the follower getting sent info by the leader. If an existing entry from a leader conflicts with a new one, if an existing entry in the follower commits with a new entry from the leader, same index but different terms, and I said commits instead of conflicts. Delete the existing entry and all that follow it. Yeah, seems simple enough, right? I'm just gonna go ahead and copy this stuff. Actually, yeah, I'm just gonna go ahead and copy this from my earlier summary because I think there's no need to rewrite it all. Let's go ahead and split this up as follows. So, merge log. I'm happy to call it just step 2 merge log, right? And then this can be split up into 2 further steps. This one followed by append new entries. Yep, so just quickly summarizing all that stuff. So there are a few questions that will come up on how to exactly implement that. When we are implementing, a few questions will turn up that we will have to answer somehow. But this is the basic idea. If an existing entry conflicts with a new one, same index by different same index. We have an index which is the same, but it conflicts because we have different terms. Why is different term enough to establish a conflict? Sufficient and necessary, equivalent to a conflict. As in, why is a disk situation? So when we have 2 different logs and we're comparing these logs, when sorry, I just had a invasive thoughts about my 2 order relations that I defined earlier and how there's another one I could possibly define for writing, but never mind. I'll think about that later. Basically, yeah, what I was saying here. So we're comparing 2 logs. And how do we establish a conflict? Well, we have an entry that is different. That's what is a conflict is basically somewhere there is a an index that there exists an index where there are two different entries at that index. That is what a conflict can be defined as. And obviously that's the negation of for all entries they are the same, which is the equality condition for two lists, or two in general, two logs in this case, are equal if all their entries are equal in the same places. And so the negation of that, there is a conflict if, by definition, the negation of that, which is equivalent to saying there exists an index where we have two different entries. But given an index, if we have two different entries, that means we must have two different terms on those entries. That's what I'm trying to say here. That's not the kind of thing you can prove easily. I can't really think of it, but intuitively it's along the lines of if there is a conflict, then two different leaders would have had to have handled those. And we cannot have two things get elected leader with the same term. That's not possible. And the reason for that, this goes back to what we were talking about way back in part A. Basically, every server issues a single vote in a given term. The chavs outside, sorry, slightly distracting. Can you imagine a parent saying, "You've just bought a new game, why are you not playing it?" Yeah, they have some problems, these chavs. Okay, where was I? Yeah, how this is all about how the elections work. How voting works. So a given server in a has its own idea of what a term is, right? It's what the term is. So it tracks term itself. And in every term, a server votes for something at most once. It's possible for it to not vote at all if it doesn't get asked to vote, but if it votes for any other server, then that server goes into its voted for variable, and that voted for variable implicitly corresponds to term, because every time there is a term increase of any sort, voted for gets set to nobody. And beyond that, voted for is never overwritten. It's only ever set to nobody. / if it is nobody, it's set to somebody. Because the server can never vote for two different things in two different servers, other servers, in the same term. And that's enforced in that way. The way that you're saying, if it's voted for no one, okay, it can vote for someone. But if it's voted for someone, it's not allowed. It can either vote for that same person again, the same server again, or it doesn't vote at all, and then its voted for variable gets reset. Voted for gets reset every time the term increases, and that's how that sort of system there is how we ensure that per term there is at most one leader, because a leader must be elected by majority. That has to be a strict majority. If it isn't a strict majority, I should fix that. But yeah, it's got to be elected by a strict majority, which is to say, strictly over 50%, strictly over half the votes. And in that way, at most one leader is ever elected, and that's bringing it back to this. That means that given that we have this conflict at the same index given that we are looking at a log entry at a given index, a fixed index, it's being, there being a clash, having different entries is equivalent to different terms, because a term corresponds to at most one leader. And so if we have a term attached, if we have the same term attached to two different entries, what that means is that the same leader processed them. And I'm pretty sure that a leader, as in the same server, processed them. And I think there has to be some sort of assertion that a leader cannot change its own log, ever. A server cannot change its own log unless it is a follower. But then if it becomes leader again later, I guess that could be a bit strange. But basically the idea is that if you're not editing logs, then certainly because every entry in the log corresponds to a term, and that corresponds to a leader, the way I've just described. Really, we're relying on leaders not being schizophrenic and being able to just tell us, okay, this entry, what happened in this particular position. There's only one. The leader's not gonna be conflicted with itself on what goes in a particular index in its log, because in principle it should be really hard for a leader to change its log. The only circumstance where that can happen is if a follower can overwrite its own log. And I hope that's fine, but I don't know. I can't really see it that must work, if you see what I mean. I'm not absolutely convinced, but on the whole, I would say, yeah, that's a pretty reasonable expectation of how it should work. So that's why, in principle, different term at same index, equivalently different leader at same index, different leader posting that piece of data in the first place. Equivalently, the two bits of data are actually different. Not equivalently, because it's possible for the same command to be picked up by two different servers in different terms if there's some sort of problem, but that is like yeah, that's strictly weaker. As in, okay, different term at same index is then a strictly stronger criterion for a conflict than the entries themselves actually being different. What I mean by that is different commands, different actual data implies different term. That's what I'm trying to say. That's the key piece of information there. Okay, bringing it back to this. So, I compare with the payload the new data from the leader. Ugh, sorry, I got distracted. Like, some of the noise is coming from these people outside. What's up? Hi. To be or exclamation mark? Not to be. Sorry. Sorry, I should have got that immediately. It's just that when I see that exclamation mark, I'm thinking Twitch bot command. If you're like on a speed run, you can type exclamation mark WR in chat to get the world record posted by a bot. So I immediately read it that way, and I was like, no, to be or not to be? That is the question. Welcome to the stream. We've actually had a few people just drop by today and post messages. It's been good fun. Stick around as much as you're interested. It's all not necessarily very interesting. Yeah, okay. So, okay, that's just a couple of randoms. I'm less worried about randoms passing by outside and being a bit loud than I am about the chavs who actually live there. That should be cool. Yeah, so that's basically deal with conflicts. Delete my conflicted log entries. Whenever I receive new data from a leader, follower receives data from leader. Whenever that happens, it can, I am the follower. I compare my log to the payload, which is what the leader sent over. That's what I mean by payload, the new information. And a conflict is, I find a conflict, what I mean by that, a conflict is defined as having a different, in our logs, at a given index, there exists a term discrepancy. Term being the voting term. The voting term is tracking who is leader, depending on how many elections there have been. And so we want the terms to be synced up, or else there was a problem because something had to be re-elected leader. That means there was a network error or something. If that happens, we delete the follower loses out to the leader, so it has to follow the leader. It deletes its log from the conflicted entry to the end and rebuilds the log. What's up? What is my goal today? That's an interesting question. What is my goal? Well, definitely finish the second. So basically, what I'm doing at the moment is trying to summarize this document. I mean, this is the paper on Raft, the academic paper, the kind of blueprint for how this algorithm should work. There's a link to it at the bottom right of my Twitch page. It's the blueprint. So I'm going over it, trying to like get a grip on everything that's going on and why it's happening, why it's written down that way. Because this is just technical details, and I'm trying to figure out why that works. And so I've gone over it once. This is the second time I'm going over it, hence second pass. Um, Definitely finish the second pass. I'm pretty. That's probably going to happen. And then I don't know. I don't even know if I have goals after that for today. I think starting to code it up is perhaps still a bit too premature. I still don't understand it well enough, I don't think. But finish the second pass and then just, I don't know, figure out what to do after that. Perhaps try to guess where in the code everything should be, come up with some ideas. Just keep going over it until I'm like, okay, I'm ready to implement this. But I don't have any. This could go on into a future stream for today. So I have another hour and a half left, maybe a bit less. I'm a bit tired. Um, just finish that second pass, and I don't know. Just see where we take it from there. So it's funny not having that many goals, But usually I have more goals. Just today's a bit. Just because I don't know, because I've spent a lot of time doing this bit already, and so just finishing that, I'll just take it from there. See what I do next. Yeah, so that covers how deletion is done, and then appending new entries is just append the stuff that came from the payload, as in that came from the leader that isn't already in the log. This I should point out, if success. So this depends on the success working. Sorry. So this is what I'm talking about now is a single instance of the leader sending to the follower some new data for the follower to deal with. And what that is, technically, is an append entries RPC. RPC being the protocol being used for servers to communicate between each other. Our distributed system communication protocol. And so, yeah, volume is fine. Okay, camera. What was I saying about that? In a single one of those can either be successful or not successful, and there's a technical definition for that, which is basically this. This here is part of the definition of success, but that's not conceptually the part of the definition. This is more just a clause that is saying every RPC should be ignored if there is a term discrepancy, in the sense that a receiver, if a sender is sending it commands like listen to me, I have new data, but the sender is out of sync in the sense that its term is old, meaning it thinks that new elections have happened since then, and it thinks that that hasn't happened, so it's on an old election term. If that happens, then every RPC is just cancelled, and so that is part of the definition of success. But the real definition is this, and at the end of last stream, I finally realized why this is the definition. I might quickly explain it now, just to see if I have my head around it. But basically, merging log, any kind of log editing, should only happen if success. If there is no success, you just bail on the RPC. I think that's legit. Yeah, more or less. It's a little bit, basically this is self-contained. This block here is kind of independent of everything else, more or less. And so a lot of what I've been doing in the past maybe 5+ hours has been to try to break things down into these self-contained blocks that I can kind of explain in conjunction with each other, so the leader and the follower collaborating. And yeah, so I kind of understand how this works. Should I now try to summarize it maybe? Just to try to kind of explain what happens exactly. I think I'll do that. But first I'll just chill for a bit, take a few deep breaths and relax, because I'm feeling a bit, I don't know, a bit jittery for some reason. I don't know if it's just my seating position is not great. It's not too bad. I'm just sitting on my bed, slumped up a little bit. I wonder if people should just meditate on stream a bit more, particularly if they've just thrown a run for a really stupid reason. Just have like a minute of just. It's nice, isn't it, just to relax sometimes. Because then the audience will do the same thing. They'll also just like. Yeah, fair enough. Sorry about that. I think honestly, README is just my Twitch page. Really, the Twitch page contains everything. The GitHub repository, it doesn't, because I'm just actively working on stuff. This is my homework, effectively. I'm not keeping it all like indexed and explained via a README for passers-by. I could do that a bit more, I think, but for the time being, I've linked the most important stuff, kind of, have I? It's a good point. It's a good point. If somebody wants to just browse my work so far, that hasn't been indexed very well, and so a GitHub README would be good. Just readme.md, and I'll just put down what is each file with a one sentence summary. Do you know? I think I'll do that. I think I'll do that after the stream. But for now, basically, what's actually important in my scrap folder. 2B is my attempt at summarizing 2B, this question. This is what I'm working on at the moment. The blueprint is just the blueprint that I've been working off of from the academic paper. There's a link to that on my Twitch page. Code so far summarizes what I've done for 2A, and is a kind of explanation of exactly how things work in my code. And then most of the other stuff is kind of old, to be honest. These are some old sketches. This is an attempt at a general sketch, which is out of date, definitely out of date by now. It even says 25th of July. Index is just kind of where are all the functions in the source code, and interface is me trying to describe outside of Raft's internals, how does it link up with the service that's using Raft. But that is like something I'm not even thinking about yet, because it's not what I'm working on actively. But that's a kind of vague summary. But I will definitely do that where I just link it up. Public, maybe somebody could help you. Yeah, somebody could. I wouldn't mind getting hints in chat. So far, I haven't been getting any, and that's good in the sense that I've had to figure everything out myself, which is cool. But getting hints is fine as well, because I get a bit of chats, a bit of interaction. As it is, yeah, it's fine. It's interesting because if I were actually at MIT, I don't think I'd be able to put it up on public, because that would be cheating. Well, it would be sharing coursework, and that tends to be frowned upon. Could I explain in a nutshell what I have already done? Sure. Okay. In a nutshell, 1 or 2 minutes I can spend trying to explain what I've done so far. Deep breath. So this is MIT Distributed Systems Project 2 out of 4. Raft. I've done Project 1 out of 4. I did it about a week ago. That's MapReduce. It's another distributed algorithm, a much easier one, and I have a Twitch collections, which are like playlists that kind of track how I went through all that stuff back when I did that before. Cars and dogs outside. Great. Raft. Raft is in 3 questions in the coursework, parts A, B, and C, and the algorithm itself is a kind of democratic consensus algorithm. So part B is dealing with the data that is getting pushed through the algorithm from the inputs through the algorithm. Everyone has to, all the servers in the cluster have to agree on what the data is, and that's the writing of the data to their logs. And then when they agree, it gets committed and then sent out the other side to the service that's using them. That's what part B is about. Part A was more about the kind of underlying, is the system working properly? Things like heartbeats, which are the leader sends messages to all the followers telling them it's still alive. If there is no heartbeat, then an election is triggered. If in a follower, if a given follower doesn't receive a heartbeat in a given time, it triggers an election, and then it literally chats to all the servers to get itself elected. This is all part A, and when it receives a majority vote, it becomes leader and does the same thing. So leadership, election, and heartbeats, that cycle I've already done. And if you look at Raft code so far, that kind of describes how I've done it. This is the technical description rather than the intuition description, which I unfortunately don't really have an intuitive description. Maybe I should have made one at the time, but I mostly just speak intuition and write down technicalities. So that's basically it. So I'm on part B, I'm on the data stuff. And I'm just trying to get my head around all those bits and pieces before finally coding them up. That's my summary. Hope you enjoyed it. Nice. Thanks. Yeah, happy that I could answer that relatively briefly. Shall I? Yeah, I guess because I'm going to be summarizing still. I'll answer that in a sec. I will at this stage, I think, go through the write section of the data cycle. How data is handled, it's in 4 parts. The write part, which is all about the data getting replicated onto all the servers as fast as possible and avoiding conflicts. If a server dies and then comes back, or like a different leader sent it the wrong information because that leader was a fake leader because the whole network got split in half or something, happens. So it's all about synchronizing those, and there's another fucking truck outside. I'm so sorry. This is like a council van. I think council vans tend to make this noise. Never mind. So it's just all about that. Getting everyone up to speed and resolving conflicts, and that's what I'm going to try to summarize before I move on and look at everything else. Okay, so question was, why am I using Go? Short answer is because the project is in Go, as in MIT, their coursework, it was in Go. I have to write Go for their coursework. Okay, Go is the perfect language for this, right? They used to do it in C++, I think, or something stupid, but Go is perfect because Go has an abstraction that is channels and Go routines, and these are excellent. So a Go routine is a coroutine that is run in a separate thread. I guess that is what a coroutine is. But basically, it's just a lightweight thread that runs another function. You have those, and you also have channels, which Go routines, because they're running in separate threads, you have that concurrency. Channels are a way of one thread communicating with another, and the way that they work is that I have a channel, something sends into the channel and something receives from the channel, and both of those are blocking operations, so the Go routine waits until either happens, unless you buffer the channel, in which case the channel can store this data, and then it only blocks if the buffer gets filled, or if it's empty and it's trying to receive from an empty buffer. And so just by using these concepts, you can link up systems that wait on each other, so the threads wait on each other, and it just kind of ticks really nicely. Actually, when I get to doing some more implementation stuff, you'll be able to see, if you watch that, you'd be able to see exactly how you can kind of implement really cool concurrency using Go's channels and Go routines. And so I'm really happy that turn the brightness down. I'm really happy that the project is actually in Go. That's awesome. Dark or Erlang? Yeah, I think Erlang is similar. Um, what do you mean by Holy Wars? Is it like battle of different programming languages? I don't know. Um, Dark I've never heard of either, so I'll give that a Google. Because every time I hear about a language that I've literally never heard of it, I'll just give it a Google at some point. Yeah. Let me know what you mean by Holy Wars. I'm curious. Yeah, there was a company that wanted me to learn Erlang, but didn't get the job, or else I wouldn't be doing this project if I didn't get that. That was like a year ago, an application that didn't work out, and they were like, "Oh, we use Python and Erlang for our concurrency." Interesting stuff. Yeah. Discussion is absolutely cool. I'm pretty happy to just chill and discuss, even if I'm not working for a bit. It doesn't bother me too much. That I'm not working, but the discussion tends to be cool. Just chatting programming stuff. Whatever hobby you have is just great to chat about it. I find even if I have no one to talk to, I just chat about it on Twitter. I find that quite cool. My Twitter is just I chat about whatever the hell I'm interested in. I just write about it. Um, cool. No, I'm not going to write any actual code today. I think it's really unlikely that I'll get that far. I have a kind of when it's done mentality, and so I want to be on top of my sketch and have a really, really sound understanding before I even start coding. That's why I've been working in Notepad. That's just generally how I do things. But the coding, I mean, it's going to happen, I'm sure, within like the next 3 days at most. Surely it's not going to keep taking this long. I know it has dragged a bit the past week because I took a 6 week break before this mostly because of the World Cup actually. Um, Also SGDQ, the speedrunning marathon. So just because of that. Rip. I'm sorry. I'm sorry. One of these days I will be coding. That will definitely be a thing. Pretty soon. I'm sure it'll be soon. I mean, I've made so much progress today in understanding how this algorithm works. Um, that I'll definitely be in a position to do that stuff soon. I guess yeah, most programming streams are more kind of people are actually doing coding, and this is more computer science than programming, but it is practical, so the programming is definitely going to come through soon. Sorry. All right. No, I'm gonna settle down and give a summary of how the write phase works. I'm gonna try to just kind of go through it in hopefully not longer than 5 minutes, and just kind of have a clear idea of how the leader and the follower keep up with each other. So that's the difference between this and what I was doing earlier, is that I'm kind of treating them at the same time and trying to understand what's going on. I am I am from London. I was born in London, UK. Still just sitting in my bed in West London, have have that English accent. Ethnically Serbian, right? Parents are both from Serbia. Both immigrated, I think, separately, and yeah, London. I feel more like I'm from London than from Serbia, but that's just normal. All right, right phase. This is how it goes. Where do I start with trying to explain this? Anywhere, because it's kind of cyclical. I may as well just start here. What is the leader doing? The leader is keeping everyone updated with, well, this is the thing. So the in phase, which I haven't described yet, this is where we start from. The service, whatever is using Raft for its consensus, has just sent in some data for Raft to process, agree with itself, and then send back as this is definitely what happened. That kind of thing. I'm not entirely sure. For our purposes, yeah, because I haven't seen a practical use of Raft yet. That's going to be project 3. But from my perspective, what we care about here is something sent in some new data, or something is sending in data. That's the interface. So what the data arrives at the leader, because every time the data send is called on a server that's not the leader, it just returns is leader false and redirects to the leader. Somehow. I can't remember how that works, but that's a different section. In. So basically only the leader starts with new information, new data. That's important. Because it's up to the leader to keep everyone updated. So for each follower, this is what it does. Next index is the leader's knowledge of which index the next data that the follower needs is at. So the leader has a list of indices of logs, and each index of this list corresponds to a different server, and the log index, the value in the list, is what the leader thinks that the server needs next. And so anything greater than or equal to that means that the leader has new information. So my last entry, the leader's last entry, most recent entry, greater than or equal to, well then what we do is we send it. We send an append entries message. This is not finished. Oh shit, I just realized I haven't finished writing this out. Just as well that I'm summarizing then, I may as well just add that in just in time. Lol. Monkaz. So yeah, we start from that, and then what the leader does is it sends an append entries, which is the message from the leader to the follower with data, sends one of those with payload, which is the bit of the leader's log, the actual data. So the leader copies its log, starting from next index, what it thinks the follower needs next, to the end. So it's always sending out all the information it has available, but where does it start? Next index. Okay. That's the very first bit. So let me just copy in. I'm going to just paste in the next section. So because I literally stopped. I literally managed to stop copying it in. These two sub bullet points here. If successful. Okay, so listen. Here, after this happens, send append entries with payload starting at next index. Okay. So here, the follower that we are talking to replies with success, Boolean variable. And so we do different things depending on if it's true or if it's false, okay? I'll check the chat in a sec. I just want to get to the end of this mini section here. So listen, if it's true, we just update next index and match index, okay. Okay, so obviously next index, it's clear what happens to that, right? Because with next index, we said next index is what the leader thinks that the follower wants next, and if there was a success, in principle, everything that the follower just sent, everything that the leader just sent, the follower received, and so the next index is one above the last index of what the leader sent out. It's the next thing after the payload. So that's clear, right? Equals my last entry plus one. I think that's it. It didn't say that in the specification, but yeah. Match index. Let me just quickly summarize that as well. This is what I think is the peer's highest replicated entry. Not entirely sure why we have both next index and match index, but match index is all about the leader tracking what it thinks the follower has. And in principle, next index is the same thing so far. So I'm going to update them to the same thing. But of course, they wouldn't both be there if there were not a difference between them. And so just bear in mind we have both of these things that we're going to, as we follow this block, figure out what the difference is between them. Sorry for not replying to this a bit earlier, but no worries. Yeah, go for it, go out. Thanks for the luck and the evening. Come back whenever. I have no qualms about people coming and going whenever they want to. That's how the best streaming works, in my opinion. Have a nice night, and thanks for stopping by and asking a bunch of fun questions. It was nice for me to chat stuff. All right, let's get this out. So next index is for each follower. Next leader keeps next index and match index per follower. And so next index is what the leader thinks should be sent next to the follower, and match index is what the leader thinks is the most recent entry that the follower has. Not committed, because this is definitely not about committing, because committing happens based on match index and after match index, I think, if I recall correctly. It says it here. It uses match index to do a commit. So it's using match index to track that. So match index is definitely what's written, not what's committed, because followers only commit after the leader has committed, and the leader only commits after it's read match index, and so match index must be right phase, tracking right phase. Next index, and yeah, again, we'll see what the difference is, but they have two different definitions that are not clearly equivalent to each other, and that's good enough for now. But if there is a success, we just set both of them to my last entry plus 1. False is where it gets interesting. Whoops. I don't want to freeze the webcam, actually. Sorry, let me just... Because I'm kind of tracking how I'm slipping down the bed by moving the camera down a little bit. It's a bit further. Oh, okay. Looks good. Camera's working. Microphone levels. Laptop is absolutely rattling now. I need to get the fan fixed. It's going tractoring. Because I was trying to set up my stream the other day, just before I resumed the project, actually, about a week ago. And I was watching someone else's stream while I was setting it up, and so the laptop just burned down, and the fan... This is before I bought this Swish fan that I'm using as an external cooler for my laptop. Just running the air under the heat grill on the laptop. Before I bought that, the laptop just melted and the fan broke as a result of both watching and kind of test streaming at the same time. It was just double shit. Okay, never mind that. So false is where I said things get interesting. So what happens in the situation of false is the following. Fails because of log inconsistency. Yes. Well, it has to say here because of log inconsistency, because it's also allowed to fail because of term sync failure. But this is something that I said earlier, is something that is just not part of what success is. That's this. This is the thing that is not actually what success is. This is the bit that we care about, and this is, I think, what we're defining as log consistency. I think that's not necessarily true. They're not clearly the same thing, but basically what I'm saying is this bit is irrelevant to how this behaves, because if this is false, that means that the entire RPC gets cancelled. And this variable is all about, should I listen to the sender of this RPC at all? And the answer is sometimes no, in situations where the sender broke down and is so out of date it's just not worth listening to and needs to be told to become a follower, basically, if it was leader or candidate. And so that's why if this comes back as false, then everything is just false and we don't even do this. And so if this is true, then we do run this code. And so this is why a success may be false, basically, is what I'm saying. And this is essentially what success being false means, conceptually. Sorry, it's the negation of this, but yeah, you get my point. And what happens in the case of false is, sorry, I just wanted to check I didn't mess that up. Minimize. What happens is that next index is decremented and then a retry happens. So I'm going to rewrite this as follows. I think that's nice and clean. And this is just next index gets decremented. Okay, so what something I should say about success? We should look at the definition of success. Here it is. Okay, because what happens here depends on what success is. So the follower replies with success. True, do this. False, do this. Okay, semicolon. Success is defined as TS React, we're just assuming, is okay. If not, RPC is cancelled. Forget about it. Not only is the RPC cancelled, but the thing that was out of date on term gets updated and is fine for the next time. That's why we don't care about if things fail for that reason. That's handled by my part A code and is conceptually completely separate from what we're talking about now. So receiver has entry matching prevlog index and prevlog term. Again, the definition of this, prevlog index and term, these are the index and term in the log of the sender, which is the leader, of the leader's, not its most, what we said it wasn't its most recent entry, instead it is the entry that, in that RPC, every RPC has a block of data, a payload that is sent, a section of log, a slice of log, because a log is a list, it's a slice of the log. Prev log index and term match the entry that is just before, immediately precedes the slice of log. If the receiver has an entry matching that, we claim that the receiver is up to date, basically, and is then ready for the next block of stuff, because it then just appends it straight after the receiver. The prev log entry, basically. If it is false, that means that it's out of date because it does not have what it should have had. And so false comes back, next index gets decremented, and then you can imagine what's going on here. When next index is decremented, the thing that's sent out again when the leader retries is, of course, this, right? Payload starting at next index. I'll tell you what, the best way of writing this is like this. So it is the leader's log starting at next index to the end of the log, and that is what the payload is. And so if next index is decremented, you can immediately see that this encompasses the previous entry. And so if it keeps failing, the leader just keeps bringing next index back until it has everything that the follower needs, and then it will succeed. And then next index and match index are updated. Match index is, okay, you know how match index is different from next index? This. So match index is a monotonically increasing variable. It's not allowed to decrease. Whereas next index is allowed to decrease. As we just saw, it was decreasing because the follower didn't have that data. But match index gets updated only in the situation where there was finally a success. And next index is updated to the same thing, but next index is allowed to get decremented until it works. I'm still not convinced in the difference between next index and match index here. Yeah, actually, I can just minimize by clicking here, can't I? That doesn't break anything. I'm paranoid because if I minimize the camera app, the webcam literally freezes. You can see it here. I'm not allowed to minimize that, so I just keep checking whenever I so much as touch it. Basically, I'm still not convinced about the difference between next index and match index. Again, the definitions are next index is the log entry that we should send next, as you can see here. That is reflected in how the leader works. And match index is the log entry that the leader thinks the follower has most recently. And that only ever increases. Whereas next index can be decreased if the leader got it wrong somehow. So other than that distinction, I still could not tell you why we have next index and match index separate from each other. I hope it's not so complicated that I have to literally try to figure out how I can make consensus work myself in order to be able to then say, oh, this is next, this is why they are different. I hope it's not that bad. So hopefully I'll be able to pick it up just by going over it a bit more. Okay. Merge log is the new bit that we have done. Let's see if we can also figure that out. So how does the follower react? You know, success is fine. Success is all about, the leader sent the correct information. And so we reply success to the leader to tell the leader that it's fine, we have all the information we need. And then if there has been a success, we do a log merger. I think that's legit. If success has failed, if success is false, I don't think we should even try to merge the log because we don't have all the information we need. So we'd have to merge the log multiple times and kind of have to apply guesswork. If we don't have the information we need, it's not just that. It's that the information we get, if we tell the leader as a follower we don't have all the information we need, then the leader decrements next index and sends even older information. And so we can't merge logs without the oldest possible information. And that's why I think merge log can only happen once a success finally comes through. And the success will eventually come through because this can't keep decreasing. I guess it hits 0 eventually. It might even hit commit index because commit index we're trying to say, because that's part of the commit phase, we're trying to say that's certain. Everyone is up to date with commit index. It's not possible for anyone's log pre-commit index to be wrong in any way. I think that's true. Not 100%. So yeah, what was I saying? Only when there is a success, so we finally have all the information we need, do we merge the logs. And so the way we merge the logs, the payload is now all the information we need as a follower. My log is wrong because it has a conflict in it, different term at same index. And so we just delete the log from that entry onwards and append the new entries that are not already in the log. So we basically that's just a case of merging two lists. Basically, once we've done part A here, the follower should be at the stage where it and the leader agree completely on their logs. So the leader's log is then an extension of the follower's log. And because the payload is just a slice of the leader's log and it has all the information that the follower needs, it should just be that we can merge the two. You know, the indices are always matched up, so there isn't a problem there. It should be possible that we can just merge the two just by doing a kind of list merge or whatever. So that's cool. If my log vs payload entry with different term are same. There is one other thing that is relevant here that I haven't talked about yet, and that's something that the MIT, its project page gave me a hint that I should check it out. And that is this. Definition of logs being up to date. That is an order relation between two logs, okay? Summary. If last entry terms differ, so given we have two arbitrary logs, we don't care who is leader, who is follower. If last entry terms, the terms of the last entry differ, then the later last entry term log wins. So term is this is again an extension of the philosophy that we are listening to whoever has the later term, even when it comes to the log. Else, Yeah, so that's the thing. Even if the logs are different lengths, we look at respectively their last entries, even if they are at different indices. And the one that has the later term wins. Else, it's just the longer log. If they both have the same term, then the longer log wins. And we have equality if they have the same term, last term, and the same length. That is, I think this should be tantamount to that because I summarized it the other day. Yeah, if they end with the same term, then whichever log is longer is more up to date. So it's not even really comparing index; it's comparing length and term. So I think that should be right. The reason I'm leaving it in my scrap here, even though I've already summarized it, is because it would take me too long to find where the original information is. It's in somewhere in the Raft extended paper, and to get a link to it, I have to find the MIT website and the course page and all that stuff. So yeah, yeah, it kind of makes sense. It doesn't all fully make sense still to me, but yeah, I don't actually see why this is relevant to anything else. I don't see when we need to compare log up to dateness. Oh shit! No, 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 no! I remembered. I just remembered because uh, I haven't actually discussed that at all because it's part of a separate section of code. So when I implemented part 2a, the election cycle, my code for when I grant votes does not take into account the logs at all, but it should. In the actual implementation, it does. So the reason I didn't do it is because I hadn't put any logs in at all yet. It was a feature I was going to add later. But yeah, basically, the condition for voting is pretty simple. Provided, so vote is done via RPC. Something is a candidate. It's a third phase after, as well as leader and follower. There's a candidate phase. Given that something is candidate, it requests votes by sending a request vote RPC to everyone else, and everyone else replies in different ways. So the default vote is false. But of course, if terms are out of sync, then it auto replies false for the same reason that an append entries can get rejected if the terms are out of sync. So that's written here as TS React. So that also applies to the vote request RPC. Sorry for using my abbreviation, but basically I'm just saying, okay, there is a condition that compares terms. And, if the sender is behind on term, then compared to the receiver of a vote, the candidate is behind on term. That means, yeah, the receiver strictly, whatever is voting, strictly dominates the candidate on term, and therefore the candidate should not be leader because it's already out of date on term, and that's the intuition why we auto reject. Beyond that, though, if the terms are okay, if the terms are all synced up, then the voter votes for somebody. If the voter has not casted a vote for anyone else on that particular term, then it votes for whoever it asked it to vote first. Else, it votes for either it votes false if anyone else asks it, and it's already voted for someone else in that term. So it's only voting first time for one. But the person it chooses first time is not strictly the first person to ask, the first candidate to ask, but it's the first candidate whose log is at least as up to date as the voter that gets voted for. And this is where this definition comes in. So we do this test to compare the two logs, basically. And whoever wins, if the so this is an order relation, and if the voter is less than or equal to the candidate on the order, then it gives a vote, provided it's not already voted for someone else. Else, it votes false, and that's where this comes in. Okay, so now I remember. I'm just going to put that in a separate section as a result. There's a completely separate section talking about votes requests. This is in parallel. This is not really part of the data phase at all, but I don't know where else to put it, so I'm just going to dump it down here. And the information for that is contained here. I even remember where it is. Lol, no I don't. I'm an idiot. No, it's here, it's here. Candidate's log is at least as up to date as a receiver's log. That's it. Add condition, votes condition, candidates greater than or equal to voter on the following. Yeah. Log up to date order relation, and then there's a summary here. That is what I'm going to actually implement. That covers everything. I still don't fully understand it, but maybe I'm ready to implement this, the right section. Or maybe I should just sleep on it and reread it tomorrow. I don't know. That's right, and commit also has its own logic that I could not tell you about exactly. Match index is what matters when it comes to commit. In the append entries receive, when it says index of last new entry, I'm pretty sure new entry is defined as what's in the payload. And it is possible for the index of the last payload entry to be less than the leader's commit index. Is it? That seems so improbable. Because don't forget, the last payload entry should always pretty much be the latest entry the leader has access to. But commit index lags behind that, because the commit index can't be something that doesn't exist yet in the leader's log. So you can't commit before you write, basically, is what I'm saying on the leader side. Follower as well, but leader is relevant. So I don't see how this could even ever happen, that the last payload entry is strictly less than the leader's commit index. I guess, but this cannot be possible, surely. Surely this is completely avoidable. Let me just put in a comment. Always send latest writes. Stuff. Okay, camera is, yeah. Don't want to get too obsessed over checking camera and microphone. But I always say that, but it's fine, I can just check them very quickly. So yeah, I've kind of started looking at commits now. You know, if sender strictly leads receiver, that means in the sense of commit index, set commit index to the minimum of, well, basically set the commit index to the leader's commit index, provided you received that entry in the last payload entry. In the last entry of the current payload, because this is happening in an append entries transaction. RPC handshake goes out and comes back. As in, an RPC is always server A sends to B and server B sends a reply. It's always a handshake of sorts. So yeah, this is, this doesn't depend on match index. On the other hand, match index, we're just trying to find all of the, we're just trying to push match index according to is everybody's. If everyone's match index is high, then we can increment commit index, is what this is saying, more or less. And match index. So match index, the important thing about match index is it's only updated. So let me put in another comment. Match index is only updated upon successful append entries. Append entry success. I shouldn't use the word successful. Next index is updated to the same thing, but for some reason it's possible for it to drop below match index. How, I do not know. It's not completely clear to me at each one of these steps what assertions we have about what we think is going on with the logs and all that. It would be good to be able to write that down somewhere, but it's not completely clear. Do you know what? I'm getting a bit confused. I think maybe I will start my next stream by looking over this and just trying to make sense of all the things that I don't understand. So it'll be a lot of talking and thinking, which is even more talky and thinky than most of my streams. So perhaps just do that. But what I will do the rest of today is just shall I perhaps summarize? This section is completely redundant now. Let me just clear up my 2b. My 2b. I just remembered I forgot to git commit after my previous stream. That's unfortunate. So if you wanted to see the state of my 2b after my previous stream, you'd have to just look at the video. Oh well, it doesn't matter. I'll definitely commit after this stream, but that's fine. As in my sketch text document here, 2b sketch. But yeah, I may as well just delete all of this stuff because I've already covered it all. As in I've redone it all. Append entry sender timeouts auto replies success equals false. That's fair enough. This is useful enough that I'm just gonna put it in here as a kind of note. Where is a good place for that? So I'm talking about the append entries receiver. Where I'm talking about success, that's where I should write about it, shouldn't I? So here. Cool. Anything else that needs to be written here? Nah, this is all done. Yeah, this is something I'm going to delete because I've kind of really moved on from this way of thinking. This was very much influenced by my interpretation of the data cycle, which I then realized should not really be implemented as a waterfall of operations. It should be implemented more as a concurrent system, of course. So therefore it's reasonable to just delete all of this stuff. Except this, which is something I'm going to cover again. So this is the in phase and this is the out phase. I've got nothing else written down for those, but I have a bit of information here. Just a bit of cleanup here. Yeah, basically. Let's have a bit of just a very quick skim of how to implement the in and the outs. And after that, I will just leave it there and say I have definitely finished part 2, and then I'll just stop streaming for the day, because I don't know, I need to sleep on it, I think, and figure out what's the best thing to do next on the stream. Perhaps just implement it and find out if it'll work, or go over it again and try to make sense of it again. Third pass for making sense. Personally, I think I will start with that, and that'll take. I won't spend too long. I'll just repass it again, trying to explain it to myself for 30-45 minutes, and then move on and just try to implement. So that'll probably be what happens next stream, I think. I'll take at least 20 hours off to think about it and sleep. Slep. Okay. So let's have a look. Last thing I'm doing today, the in and the out sections. So the bits where Raft interfaces with the outside world. How does data get into Raft and how does data come out? Data coming out is easy, actually, so I'm going to start with that because I'm pretty certain I know how it works already. So it's all about the apply section, which is covered here. Yeah. If commit index, so basically this is an everyone tracks. So everyone is constantly paying attention to the following. And this is last applied track. Is basically what this is. So here it is. Oops, careful, don't break the camera. Where is it? If commit index is greater than last applied on literally any server, and it's not communicating with anyone else, it is just checking periodically. If commit index is strictly greater than last applied, increment last applied, and apply log at last applied to the state machine. So this very much just looks like a Go. This is an implementation detail. In the interface, my interface scrap document, basically, apply channel is a channel that every Raft server has. All of the servers in the cluster have their own apply channel, and every time I'm ready to apply something, I just send that into the apply channel. This is already implemented in the project itself. I don't have to make myself an apply channel. It was there when I received the project from MIT. This is why I say it's easy. That entry gets sent into the apply channel, and last applied gets incremented, and then that just keeps happening. So it's just another concurrent coroutine that runs infinitely often, basically. So out is easy. In is a bit more confusing, I would say. Where is there information on in? That's got to be written down somewhere. Here it is. Yes, here it is. If command received from client, append entry to local log, but this is something only a leader does. Respond after entry applied to state machine. And that's all it says. leader handles, because this is not something the leader needs to actively track, because it is an event kind of thing. Basically, it's not actually an event. It's just that a function is called every time there is new data, and so that's why we're not having to track it the same way we're tracking everything else. Instead, it just happens automatically. It gets called whenever there is new data. Let me just write it to my usual convention. Append to my log. And the other thing is respond after entry applied to state machine. But this is the thing, entry being applied is the out phase. Response. Respond to, I think it is the caller. Not entirely sure, but let's just leave it at that. And then, yeah, let me just quickly load up Visual Studio Code to cover the what Visual Studio Code has that is useful is some comments that MIT provided that cover the start phase, and so I'm just going to reread those, and I think that'll be the last thing I do today. So that's here. I even remember where it is. It's in the comments to the start function. So start is called with the command. The service using Raft. This is the inputter / outputter, I don't even know, the thing that Raft is communicating with in the outside world, wants to start agreement on the next command to be appended to Raft's log. If this server isn't the leader, just straight up return false. Otherwise, return true for is leader and start the agreement. So yeah, that's in basically that's what happens. So it handles start, and this is what it does. Start the agreement and return immediately. There's no guarantee that this command will ever be committed to the Raft log, which is I think the final apply thing. Since the leader may fail or lose an election, even if the Raft instance has been killed, this function should return gracefully. And the indices are the index that the command will appear at if it's ever committed, the current term, which is the term that goes into the log for that entry. That's the entry's term, is the current term, and it's the second return value. And the third is just, it is leader. You know, if the server believes it is the leader. And that's it. So it doesn't give me that much information on how it starts the consensus. Well, do you know, from what I've seen, having read everything else, I think it is sufficient to just append to my log, because then everything else will just work. Because then it gets, if the leader appends to its own log, what happens next is this gets triggered immediately, right? Well, not immediately, but when it next gets triggered, because this is a tracks thing, meaning it's something that's getting checked for all the time. When, if I append to my log, I thereby increasing last entry index, and last entry index then starts to exceed next index, and therefore it starts replicating and the algorithm begins. So that's it. I don't have to put in an extra channel or whatever I was thinking before. This just works. And that is my second pass completed. Finally, after I have spent a long time doing this second pass. It's been maybe 4 hours. It would have been less, definitely, if I were not streaming. But part of the fun is that I'm trying to teach myself to speak everything that I'm thinking about, and just be learn in that way. It's a useful skill for interviews, I guess. So yeah, that's it. I don't strictly know what I'm doing next. I have to say, I think I'm briefly going to go over everything. When I say everything, I mean... Oh shit, I have this information here as well. Wait. Let me just delete this because I don't need it to be here. Leader appends data to log is all that happens here. This is either wrong or out of date. And yeah, this is stuff I've already written about as well, so I'm just going to straight delete that stuff. Yep, so I'm going over this. I'm going over all this, but not really all of it. I'm just going to... data cycle, for example, I don't need this that much anymore either. State variable is okay. But basically, I'm going to go over this stuff. Starting here, group per data cycle, where I've just organized everything in my data cycle model, and I'm going to just go over all this stuff in my thinking to try to figure out the reasoning for it. I don't think I'm going to be able to figure out all the reasoning, just because it's so complicated. I think I might fail to figure it all out. In which case it's fine, because I have a very clear... All the implementation details are pretty much clear to me at this stage, I would say. I'm feeling quite confident about implementing, and so after just a little bit of trying to understand it, I think I'm just going to make hay and implement. So yeah, that's it. Tomorrow is my next sesh. Tomorrow is when the implementation starts, so get hyped for that. We're going to do some actual coding, maybe half an hour to 45 minutes in. I don't know how long. I don't want to predict the future. I always get it so wrong by like many hours. Even if I predict only like 2 hours in advance, I get it wrong by many hours. Go figure. But as it is, I'm happy with this. This is kind of clean and understandable, so I'm just going to leave it there. Oh, okay. Well, that's the end of my day, my work day. I've done, pretty much 2 hours of work, just a bit less. It's been 4 hours of work, a bit less. So it's been about 3.5. Yeah, not much more to say. Next sesh is going to be tomorrow at, I think I said 7 p.m. I want to see if I can pull it into daylight slightly more. A bit more daylight. So 7 p.m. if I'm feeling a bit tired or behind on the rest of my day, I might put it off back to 8, or even 9. But 7 p.m. Let's just say 7 p.m. for now. I will just knuckle down and we'll just be doing implementation, as well as a final attempt at understanding the theory behind Part 2b. So that's basically it. Part 2b theory recap for the final time, and start the implementation, get to work. Sketching is basically finished. I have to say I'm so happy that that's finally done. And that is happening at 8 p.m. tomorrow. Gotta get a good long night of sleep, seriously. I'm feeling more and more... Well, this is what happens when you stream in bed, I have to say. Alright, thanks for joining me today. Lots of chat today. It was good. And that's basically it. Yeah, I'm just gonna take off, go sleep, and perhaps go watch some streams of my own. Wind Waker HD any percent speedruns and that kind of stuff. All good. Okay. Thanks for joining me today, and I'll see you tomorrow at 8 p.m. for a bit of theory recap, and finally some implementation. Bye bye.